And then this is on. There we go. Off mute. All right. Welcome, everybody, to tutorial. This is prefix filtering black holes and protecting your business. My name is Greene. Been around Nanog for quite a while. You can find my name out there. Just Google it and stuff like that. I'm now working for Juniper. I did a switch just recently. My colleagues over here in endeavoring in this effort got Dave Barak from AT&T, Mark Pryor, who just also at the same time and this is not coordinated, but he also joined Juniper at the same time. But Mark I knew from Asia Pac when I lived out in Singapore days, and he's been doing a lot of this sort of work with the IRR out in Connect.com and then RNet and RNet. What is the RNet? Yes, the Australian Academic Research Network, right? So the goal of the session is we're going to what happened post-mortem right after the last Nanog in February. We had an industry event when it comes to prefix filtering. So a bunch of us in the community decided, okay, we're going to have to take this area of our industry, which is routing policy, best practices of routing policy, how we do it, and start to refresh the materials. The last round of these materials happened back in 2001, 2002, 2003, and there was a break, and apparently we need to keep refreshing this within the community. And this sort of refresh and working on this sort of basics is part of what the Nanog tutorials are all about. So who here, just as a general question, who here, raise your hands, operate their own internet route registry? Anybody? A couple. Let me tap into your questions here, tap into expertise. Who here is the person in charge of routing for their autonomous system? All right, quite a few, good. So this is, some of the materials and some of the thinking will probably help you out with this because that's what we're about here. This slide deck will be provided on the tutorial page, so when we get through with this, we'll push up the PowerPoint slides. So we'll have a PDF, we'll also have the PowerPoints. The idea behind this is kind of like a philosophy of part of our job, everybody here in this room, is we got to convince our management to do certain things. We got to convince our peers to do certain things. And a lot of times it's very helpful to go and cut and paste a slide. And it's really funny, as I was refreshing the stuff and I was looking at the IRR material, I was joking with Mark, and I'm noticing that slides he did back in '98, I'm seeing in other people's presentations in 2001 and 2002, 2003. Mark doesn't even know people are using his slides. But that's how we need to operate, right? Because what's our goal is we're trying to convince our management to do right things. So those are these slides are out for. Our learning objectives, this is kind of like the tip of starting like each Nanog for the next 3 to 4 Nanogs, doing a more and more detailed sort of tutorial. So those of you who are regulars at Nanog, and even if you're not a regular at Nanog, like the next Nanog, we're going to get more details into the policy language, more details into refreshing of the new filtering technologies, because a lot of the materials out there, I know both Cisco and Juniper have more detailed and more advanced filter and policy languages, policy tools available to them. So we want to get that knowledge out to the community. So view this one as kind of like, this is the context one. And the idea behind all this is setting up as a Nanog curriculum is like a year from now, you can take somebody on your NOC team and you just say, watch this tutorial, watch this tutorial, watch this tutorial, watch this tutorial. So you have this kind of like tutorials. Because that's one of the functions we do. I don't know whose idea it was at Nanog, but I love it that all these are taped, right? And we can use these tapes to bring more clue to the community. So this is kind of like our goal with it here. And here's kind of like the outline we're going to go through. We're not diving into any router configs or anything with this session. Remember, this one is just the context overview, the threat, why we need to do this, right? We're going to talk about why we're doing this topic again. What the threat and problem is, know your network, have your own prefix database, and this is going to be our big emphasis of the first thing of have your own IR, and we'll talk about getting into that. Some of the principles of it, some of the enabled capabilities where we'll talk about, what do you do when you get hijacked? And what happened with, in the case, what triggered this with the YouTube Pakistan event. So why are we doing this again? We already have a lot of good materials online, and especially in a nanog, when you look at the nanog tutorials, we got some good sessions out there already. All right, so if we already have good materials out there, I mean, you can go out there and, like, for instance, a really good session, Dan Godlin, right? He did a really good session back in 2004. You can watch him online. It was like a 2.5-hour tutorial walking through all sorts of good stuff out there. So we already got some good materials out there. And this is just a subset. There's more talks than this. There's talks all over the place about routing policy. You go to any of the operations meetings. We even got one-day tutorials out there. Like Wright has got a one-day tutorial you can sign up for, and all its materials are online. Right? And if I poked around for it, I'll probably find a VOD of the tutorial somewhere. They do a lot of hands-on work there. So why are we doing this again? Pakistan, YouTube, all right? The day after, all right? And it's had a different impact, and we'll talk about the different impact that's had to the industry, because this was something where, that it impacted, people started scratching their heads saying, what should we do about this? Because, we're doing all this training, yet these incidents still happen, and in this case, this is a very publicly visible incident to happen, because lots of people go to YouTube for doing things. Well, what if it happened to a different property? Right? What happened if it was malicious? This was an accident, right? So it wasn't like, Pakistan government trying to black hole on the entire internet. It was, they were only trying to black hole it within their country. It was an accident, right? And it was a preventable accident if they had the filtering policies thought through, right? But they didn't, and we have this collateral damage on the net. So this is collateral damage. What happens if it becomes intentional? Dave, you guys have anything to add so far in context why we're here?
Yeah, it's not just a single failure on that led to the accident. It was a failure on both the part of Pakistan Telecom who let a bad route leak, and then it was the failure on the part of every single one of their upstreams who carried a bad route. So there's a lot of opportunity for us to make the internet in general a bit more resistant to accidental hijacks, let alone more malicious ones.
You had a thought. And feel free to come up.
Well, Rüdiger Volk. Well, okay, actually, I would like to be a little bit more precise. It was a failure of the actual carrier, Pakistan Telecom. It was a failure in filtering by its upstreams, and it was a failure in the peerings at the highest layer. And each is actually a different problem.
Yes. And we'll get into the overview of those problems, and then in future sessions we'll get into, okay, what tools could I actually configure on my equipment, right? Because to get down to the details of this, we get the tools. What we're going to be, I think the key thing we're going to be driving here is, how do I prepare for that? And the first thing we're seeing out there that we need to prepare for it, for the whole industry to move forward, is, having your own information collected in one central location on a database that can be used by multiple parties and eventually connected to the rest of the internet. We'll get to that. All right. So our approach is drive simple recommendations. Start simple and start working out. When I looked through what we were doing before, like 2001 to 2003, the last wave where we were talking in detail about this work, is we were in the weeds really quick. And one thought we had was, maybe because we dived into the weeds really quick, get into all this, the RPSO language sets, and that a lot of small networks, a lot of even large networks would go like, wow, this is too hard. This is a lot of work. I don't know if I'm going to be able to convince my management to do it. So the idea here is we're going to start simple, collect all the wisdoms we got, make sure people understand the consequences of it, and then kind of drive forward with best common practices. One of the actions in work, and if there's anybody here that's interested, I'll bring it up again, is we're starting up a internet draft. So, get an information RFC out. Maybe we can get it qualified as a BCP status of how to do the filtering policies. So that's one effort starting up, because sometimes your bosses, they need a document. They say, why should I do that? It says, well, there's a best common practice we have to follow. Here's the document. And then your management will say, okay, whatever you say, whatever you say in the document. I mean, it's kind of like, what does the community need to get the stuff justified? And so that will be one of the things we get going. So business impact. There's a perceived threat out there of bad route information leaking out. All right, it's happened from it has happened and it will happen again. It happens from mistakes. It happens from policy failures. There are bugs. There's also intentional. All right, and the intentional you don't hear a lot about, and that's planned because the people usually doing intentional don't want you to find out about it. Right. Usually the ones who perpetrate are the criminal side of the internet industry. The intruders are understanding what privileged access to routers are, right? Routers are bought and sold on the net today in the criminal economy. There are people who specialize in finding routers and breaking into them and then selling them to others who will then use them for their crime, right? So this is a reality today that happens, buying and selling routers out there. And the threat's growing. We've had, like one of the big ones people write about a lot, 7001, where you had a router issue. It deaggregated the net that flowed through, right? So what if 7001 was used as an attack? What if a MultiHome CPE was violated and deaggregated the net? Because we got more and more MultiHome. Every single one of your MultiHome customers, what's stopping that router or somebody breaking into that router from sending out hijacked prefixes and things like that, right? Do you trust them? Because the reality is what we see out there, especially what I see from where I worked at before and where I work at now, when you work with the customers out there, is that you don't see a majority of service providers who actually filter on the customer side, right? So that's one of the issues that we'll be talking about. So what's the impact of it? Well, garbage in, garbage out. So you get a router, a MultiHome customer. You can make a mistake. It could be intentional. It could be a spam job gone bad because people use these for spams. And all of a sudden you say, hey, let's advertise the entire internet with /24 or more, right? Small little routers have a lot of memory these days, right? So you get a small little router and you can go through and set up a little tool and advertise the internet /24 and advertise it all out. So then what happens? The two upstreams that the MultiHome customers connected to, they go, oh yeah, no problem, we'll accept those /24s, right? So then you have the internet start accepting these /24s, and this gets propagated all throughout the network. I mean, in BGP, something happened on one side of the net, the other side hears about it and sees about, right? So it gets propagated all the way through if you don't set up your filtering properly. And so the rest of the internet, minimally what's going to happen is you're going to see a lot of activity. It may not affect your business, but you're going to see a lot of activity. But you can see a lot more going on, all right? Let's advertise the entire internet /24. You can have everything go, head down that way. Now, some like this stuff, like I've seen, like in one country, 99, I think, one country advertised a /8 out of the AP NIC block. Didn't configure their router properly. And all of a sudden, you had all this traffic from AP NIC all head down to that one country. Boom, their links go up. And what saved the situation was their links blew up. Right? So the links congest, BGP drops, the advertisement gets withdrawn, right? And they flap for about 2 hours that way, all right? So let's take that scenario. I'm going out there and sending out a huge AP NIC block. I got a transoceanic link. I advertise it. Everybody sends traffic down that link. The link saturate, it drops. I get a withdrawal, okay? Everybody tries to stabilize. Before it gets to stabilize, the link comes back up. Advertisement goes out again, traffic goes down, link goes down again. And this was going on for like an hour, all right? So you get things like this, and that is causing a lot of pain throughout the net, right? So this sort of stuff affects everybody who's connected with BGP in some way, shape, or form, all right? So this garbage in, garbage out, it does happen, right? Fortunately, we don't have people out there who intentionally want to, like, let's do this just to cause pain to the net, right? You're not going to see the criminals go out there and do it, because the criminals are saying, hey, I need the net to make money. So when you hear, like, Team Cumry and others talk about the miscreant economy and stuff, criminals don't, stay away from these attack vectors because there's no money in it. They want the net to be there so they can make money off their other schemes that are going out there and stealing and doing credit card fraud and things like that, right? You can't do a phishing attack if the net's not working, right? So they'll keep the net up with that. But we do got people out there who want to cause terror and other activities out there, and that's one of the threat vectors in there. And we have situations like we did with Pakistan and others with it, all right? So this is why you need to care about these things. We talked about these different mechanisms to actually build more resiliency to your system. I don't know.
I did run across one situation remarkably like what you're talking about in a prior company I worked for. A misconfigured load balancer decided to announce a /16 as a series of /32s. And took out pretty much a region of the ISP because it was accepted and then propagated to the next router, and then those routers crashed. So that was the danger of even having a prefix filter, where the prefix filter allowed a /16 LE32. So
yeah. So Mark, have you seen any more from your operational days of?
No, I've been relatively lucky. I haven't seen that. I've read Nanog and that sort of thing and thought, oh, isn't that good that it hasn't affected me? But perhaps that's because I've mostly been on the end of one of these long transoceanic links, and it usually takes some problem to actually get down there.
Yeah. So the good news around all this is the techniques we're talking about right now and that we will be talking about in future tutorial sessions are not techniques that need to be created. They're already there. So we're not talking about anything that we need to build this. We haven't created this technology yet. We're talking about technologies which exist today, which you can download today, which you can configure today, all right? So we know these techniques work because we've seen, like in 7001, I know people at service providers who said somebody had to call them to let them know something was going on because they had prefix filtering policies that protected them. And they saw no impact to their customer base, right? So we know these techniques will work because the people who do it say that it works for them, right? So we're not talking about, things that is rocket science in the future. These are things that you can go back and today or log on while you're in there and start looking at your network and thinking about how would I do this on my own network. Bad news is we got more and more multi-home customers increasing, right? Because as more people depend on Internet Protocol as the telecommunications network of the future, and they need to be building resiliency for their businesses, they will be multi-home and out there, and that means they'll be BGP speaking, right? So we got more and more of this. Really, really bad news out there is many times people will go out there, and even if a vendor goes out there and makes a policy, it says, you cannot telnet into the router unless you set a password on it. Well, what's the person do? They put a password in there that's easily guessable. Like, oh, let's put in Cisco. And the joke is even on Juniper routers, a password to put into Cisco. So what do? You go out there and try to connect via telnet and go, what password do you try? You try Cisco. Ah, okay, I broke into a router. Now, somebody who has that low security posture, you have somebody who's BGP multi-home, and they don't even know that they got broken into, right? So there's more of this stuff, going on. So it's impact with it. Some of the attack vectors you'll hear about, the denial of service to customers. If I hijack somebody, a traffic redirection interception, like instead of having people go to your DNS server, I'll have your DNS server come to my DNS server because I'll hijack your IP address. And then, you won't even know that people aren't resolving to your authority. They'll be resolving to my authority. Then when we resolve to my authority, what can I do with that DNS information? All right, so you can hijack a whole service over and do a bunch of interesting things with it. Prefix hijack and AS hijack, and I've seen one case, and one customer of a service provider getting an entire AS hijacked when somebody decided to just inject an autonomous system over and on the other side of the internet, and the service provider accepted it. It belonged to somebody else, you know. And you have an AS advertised here and an AS advertised here, and you know, whoever was closest, that's where you went, right? So we see all sorts of it. So a prefix hijack, just to clarify, make sure everybody's on the same page. A prefix hijack is, here you have a customer off the side, he has XYZ/24 as a prefix, okay? And you have somebody on the other side of the net, he breaks into a router, and he decides, I want to pull all the traffic down for that particular web server over here. Instead of having gone to their web server, I'll have it go to my web server. And so he'll advertise a more specific route on his side of the net. He advertises that more specific route, and if that upstream does not filter, that more specific route goes out, and traffic starts going there. Now, it may not be the entire net, depending on how the net's set up, because the way it works is every single router makes its own decision, every autonomous system makes its own decision. So it may be just the autonomous systems closest to that router who are making the decision. But if this is a guy who's like, I want to do this and go to a web server and do it for, you know, criminal purposes, like that web server is a bank, for instance, right, as a form of hijack the bank web page. You know? If I get enough passwords on there, that could be a profitable sort of criminal activity. And this is what we talk about as an intentional hijack, right? Now, we see this most of the time, the most frequent activity we see with this, I don't know if it'll be interesting offline if people see more of it, the most frequent hijacks I see with this sort of stuff is with spam. So what you'll have is somebody who takes a computer, injects an address in that belongs to somebody else, sends out their spam job, right, with the computer that's behind the router, and then disconnect. And they only do that, be connected for like 5 minutes, send out a whole bunch of emails, and then disconnect and wait, and 2 hours later open up, advertise, inject again, disconnect, and do that for the run of their spam job. So we've seen those sort of things, and that's where spammers are the ones who usually buy up broken into BGP routers these days, and so they can do that sort of activity. So I don't know, have you guys seen any other nefarious hijacks?
I'm not sure what the source of them is. I mean, I've seen the spammers. I've seen the spammers do that, but I haven't. And I've seen other hijacks, but I'm not sure why they're hijacking. So I'm certain they're doing it for some reason.
Another nastiness is when you think about what if, and this is the what if sort of scenarios. What if you had, since these broken into routers are being bought and sold on the net in the criminal underground, what if you went out there and bought 20 of them, and then with those 20 of them I decided to inject a whole bunch of nastiness. I could deaggregate, I could send, pick a target and advertise it. I'm New York City. I could take all the New York City emergency response services and advertise all the New York City emergency response services, fire department, police department, hospitals, everything, and advertise it over there and advertise it from all different parts of the net. So I'm hijacking those properties, those IP properties out there, and then do some sort of physical world sort of attack, right? That will cause a lot of headaches with people. And the thing to think about is this. We're all talking about this where this is the internet. But what we as a community have to remember is long live the internet's dead. It is the future of the telecoms infrastructure. This is telecoms. I mean, telecoms of the future is running over IP. Everything's convergent over IP. This is NGN. So now you got a hijack and you ask this question. Hey, Mr. Telecom regulator, who's upset because my phone service was down for 2 hours because of a hijack. What do you explain to them? What do you explain to your citizenry where, a hijack has caused damage in your network and you couldn't get 911 services working? Right? So the impact to this, and this is why I said the impact to your business. Back in the 2001, 2002, 2003, it was still, the internet would have been good, would have been, how do we support, the 3G? And the 3G I'm talking about is, 3G, games, girls, and gambling, right? So that's what 3G All right, so you got your 3G is what we were building before. Now this is the future of telecoms, and future of telecoms is about, you know, critical telecoms infrastructure used for critical things that binds us together, right? And so what do you tell, you know, the regulator who's upset? Because these are sort of things we get monitored on as an industry. And the impact of it, and this is something I scratched my head. Me, who's been in a vendor for going on, you know, 13 years I've been in a vendor, 12 years I've been inside of a vendor land versus operator land. You know, and a vendor, you know, we love to, you know, sell you stuff, right? You know, but, you know, what is put myself in the operator's shoes and go like, why are we, you know, allowing where, you know, the thing with BGP and routing, right, and the way people do this stuff, I can be on one side of the world and I can put more prefixes, more communities, more ASPs, more activities, more flapping, more changes, more things in there. And then on the other side of the world, I got to have more memory, more FIG capacity, more route processor speed, more routers. I got to do, in other words, something that happens on one side of the world impacts my OpEx and my CapEx. And that's one of the things I always scratch my head about. And for a while, you know, me and a colleague of mine, Hank Neshemer, we were trying to say, with Cyber Police, trying to say, can we keep like the growth of the table? Just pick one thing. Keep the growth of the internet table, you know, managed by actually getting more clue in the community. And we did that for a year, and that actually worked out. We actually showed where we tampered out, and we, you know, had thousands of prefixes withdrawn just by getting people to do proper configurations that they didn't have no clue how to do. We just taught them how to do it, and they did it. So we kind of know that there's a lot of the routes that are out there today because people don't have any clue of how to do it properly. It's a clue issue, right? And if that clue issue is costing me money, you know, it's always amazing how the operator community would rather pay vendors more money for the equipment than to go out there and work on finding ways of cleaning up the community, you know. So this is an interesting sort of thing about the impact with it. It's just the way we as NGN is being plugged in together. It's an interesting sort of data point infected. So now I'm going to hand over. Mark, you want to kind of go through some knowing our network.
So one of the key things is if you run a network, you should know basically what's out there. Particularly, you should know what routes your core infrastructure, servers, routers, that you're trying to route on the internet to get access to, and what routes your customers, you have a contract with them to provide some service to the internet. And you've probably got a whole range of people within the company who want access to this information. There's people who are going to bill for it. There's going to be a NOC who are actually going to chase down problems, and being able to identify what networks you're responsible for on the internet is probably a useful thing. Okay. So if you want to keep track of these networks, you could have a group that's running spreadsheets because they're the salespeople and they've been out there selling. You could have your finance people who are putting all this stuff in an Oracle database because they want to bill. You've got a NOC team that have probably got it on scraps of paper on whiteboards because they've just been configuring stuff. But what is more convenient or more useful to the organisation would be to actually consolidate all that information into one place. And over the years, we've been using WHOIS databases to store this information because originally the allocation of the IP numbers has come from an IRR who have had it in a WHOIS database, so they've created this code. You want to say something?
Please properly distinguish between WHOIS databases and the allocation registry and the routing registries, which you are calling IRR. It's something different.
Well, it's something different in the manner of the data that's in there, but it's sort of leveraging the same sort of database in multiple ways, I would have said.
Well, it's different type of data, and it's different type of maintenance of the data. The parties that are allocating and documenting the allocations is actually creating something very different from open databases where everybody can store whatever he claims should be a correctly routed route.
Oh yeah, there is the assertion of truth. The IRRs who have the data and have given it to you, they can assert that they have in fact given it to you, whereas another organisation can assert that, well, I have control of this without actually having any authorisation to do that, I guess, what you're getting at. But what I'm saying is that we can leverage this software that's been produced to our own advantage. And there's a couple of URLs here for at least the IRD was developed by Merit, and the right database that a number of the internet registries use. And I'll come to the ISC one in a bit. What I want to do is keep this simple. As Barry said, when we've gone through this in the past, we've sort of dived into what is RPSL and how this is great software and all the stuff you can do with it, and people's eyes glaze over, so this is going to be difficult. So what I'm hoping here to demonstrate is that you can keep it simple by just picking a small subset of RPSL, and further down the track you could go down to the depths and describe your policy in detail using these tools if you wished. But what we want to do here is just encourage people to start filtering and start thinking about filtering. So we take the small part of just registering your customer routes in a database that you control. As I said, we don't want to scare people too much. We want them to actually do stuff.
So, so add on there. So if I'm an operator today, and one of the things we're missing is, like, if I call another NOC and I ask them, okay, I see a prefix coming out of your network. Can you tell me whether that prefix is a customer of yours? Because I think I got a conflict. I think I got a hijack. I think that prefix belongs to my customer. Can you look at your database to figure that out? Because I can't figure it out. You know, that could be a MultiHome customer. I'm not quite sure what's going on, right? What's going on with this? And you as a service provider should be able to quickly look in your own database to say, yes, this is true, or yes, this is not true, based off of your policies. Many times when I've been asked to help work some hijacks, I'll call up the service provider and they go, well, let me check this, let me check that, and I think it's over this data. Wait a minute, it may be over in that database, or let me pull up the Excel spreadsheet because we keep it all in an Excel spreadsheet, or that's over in the sales provisioning database and we don't have it linked to over here in the routing.
Or they're going to look it on the router.
Yeah, and a lot of times they get on the router and says, well, I don't see it on the router, but you sure we're advertising it? I've had that too.
Yeah, and there's even a half step before getting into customers' routes, which is your own routes. So the routes you yourself have been given by the IRRs. Registering those first before the ones you give out to other people is even step zero.
So what we're looking at is when we're looking at all the different work of us going forward, how do we increment, how do we get better post-mortem to what we saw with the Pakistan YouTube incident, is focus on that service providers should have a central repository that they can pull upon. If you have a central repository you can pull upon with this route and policy information, we actually have a whole span of work, of tools of work that you can use, and you can use this tool set for a whole bunch of things,
stupid question. As you're talking, it sounds like you are not making a point out of that, well, okay, all this data should be published in a way so that everybody can have access to it.
That's certainly ideal.
So what we wanted to, a lot of times we emphasize that point first before you have it where your own management can get to it. All right, so when you look at it, the business processes, when I look at service provider as a business, I look at sales needs access to this, provisioning people need access to this, your routing policy needs access to this, a lot of people need access to it. If you get that problem fixed first, and you're using the tools that have been created for this to do it, then the next step would be, okay, now let me peer so everybody can then, outside the community, if I'm another service provider, I can then use your database as the authority for your policy. And I can publish that and mirror that out.
We all agree it's absolutely essential to have this database to know what prefixes you're advertising yourself, what prefixes your customers are giving you to advertise. It would be very good if everyone were willing to share that data with each other, because then you could make much better filters. Problem is, you'd also be sharing your customer list with your competitors. Some people might object.
Well, but to answer that, to be fair, the customers are already shared. If you're routing their routes on the internet, everybody can already see them.
If you object to publish your customers' routes to the routing table, to the global network, well, okay, you will see your customers leave.
Point well taken.
Yeah, I think that what we're trying to drive at this time is try and work out perhaps reasons why perhaps it didn't work last time, why we had all this training and still there was not a lot of deployment of this stuff. So this time around we're thinking that perhaps if we target what benefit it is for you first, rather than what your peers may benefit from having that information available. So if you do it just for yourself, then there's a benefit to the community by you tightening up your own backyard and the controls that you might place on the announcements you make out of the internet. The next step is then a small step to say, okay, I've got this data, I'm familiar with the tools, I'm comfortable to make this data available. Now I can actually export it and make it useful for other people to now leverage this information. But then you get to the problem of it's okay that you know that this customer is your customer and these are the routes they've told you that you should expect from them, and you've done some back office process to verify that these routes they're telling you are theirs are in fact theirs. But then if you publish that information out to the internet, your peer may not believe you because at the moment there is no way of you verifying that the chain of authority from the IRR to the customer to you being able to announce that route, especially if it's not a BGP customer.
Well, in most parts of the world, unfortunately, what you are saying is true. It doesn't need to be so, because the technology that's out there and has been deployed over a decade actually allows, for example, in Europe, that the IR delegations are in the database, and the security technology, pretty weak stuff, but still security of some kind, allows to actually get the authorization, or, well, okay, only if the authorization is really there, to actually register the routes. So, well, okay, actually there, you have a chain.
Yeah.
And stronger mechanisms and databases are forthcoming and will be luckily available globally.
Yeah, I guess that we want to start this process in parallel to that, because this part of the planet, certainly not Europe, no one pick on Europe, is a bit slow.
Yeah, well, okay, the bad side is that, well, okay, actually building your own database and then publish out from there is kind of not going to help for the strong stuff that's going to come. And actually starting the way that you first make sure that everything that you are actually injecting into the network goes to in a public documentation and becomes available for everybody, actually allows you to also use the public documentation for your internal purposes. So, well, okay, that's at least a different way, which actually jumps over the first step that you are proposing of first building your own database.
The challenge is when we approached this years ago as start by joining up and publishing all of the routing policy in the public IRRs, it wasn't done. So there is a resistance to going straight to that, whereas there's an obvious business benefit to having all of the information in a single place. All of the various business consulting type people are getting big on single databases and single authoritative databases, and they're getting into that idea now. So that's an easy sell to management, to say there ought to be a single place where we know our own customers. And really, and it's in fact an obvious thing to say. And they would say, wait, we don't have that? So this is the idea that you can answer a question. So when some other provider calls you, some other provider's not, calls you up and says, gee, is so-and-so your customer? You can say yes or no authoritatively without having it be an ordeal. That is an obvious business benefit now that is an easy sell to management, as opposed to changing the way people do business, which is harder. I mean, it's harder to go directly to, well, we're going to require that all of the policies, all of our routing policies, are influenced by publicly available data. It's a harder immediate sell until you start seeing the benefits from the publication.
Okay. I'm seeing the problems, and well, okay. I have been watching for quite some year and seeing that, well, okay, the things that would be nice don't happen really. But well, okay, I get funny feeling when you say the idea of a single database is so obvious. When thinking about it, I feel like, well, okay, you are talking about 5,000 different single databases, which seems to be kind of a contradiction in terms.
But inside the single organization.
Yes, but well, okay. One of the problems of having multiple databases usually is redundant storage of the same information. And redundant storage of information where you claim that each copy of a storage is authoritative,
right,
quite obviously is the even more creepy thing.
Right.
So, well, okay. What I'm seeing is that, well, okay, we are hopefully very close to getting a globally homogeneous database for authoritative data that will be hopefully the single database that's going to actually do the trick, and that's not going to be the private thing of a single company. Half a year away.
They have 167 slides. We've seen 12.
Yeah, it's just sure. Sorry for crashing the party.
That's okay. So of the multitude of objects that a WHOIS database provides, this is the core one as far as filtering is concerned. It's the route object, and you look at this and go, oh my God. But as you may notice, most of this stuff is optional, and probably hardly anyone actually uses it. So I go to an example which is fairly ancient, a number of jobs ago, stolen out of an old slide pack. This was one of the infrastructure routes for connect.com.au that is now part of Telecom New Zealand. after a couple of takeovers. But this gives you an example of the base information that's stored. So you've got a route, so a CIDR block, a description, and in this case, the bit in brackets is in fact the customer code to look up the Oracle database that finance are going to use. The origin AS, this is AS 2764, it's the infrastructure route. Notify in a public routing registry, when anything changes, it'll use the notify to notify of a change. The next one is a reference to a maintenance object that describes who maintains this object and what access control is needed to change the object. If you're just using this as a convenient mechanism to store information about the routes, you may not in fact be using the maintainer record, and you may actually be manipulating the database directly. And then a record of who changed the record last. We discovered that the spammers were actually using this, so we started using an address that didn't go anywhere. And this is a source. The source is the identifier for the database that this record is in, and this is RADB, not the internal Connect database. So over the years, there have been a number of people who have developed software, some of it in-house, which has never escaped. Some of it is public domain. People have just written code that sends queries to WHOIS servers to pull these entries back. But there's a tool set that is sort of looked after by ISC, where looked after should be in inverted quotes, because really they're not doing a very good job of it. But it does exist, and you can download it, and it's probably fairly hideous to build, but we won't go there. But it does support querying two of the types of the WHOIS servers, and there's a piece of software in there that can actually write code fragments for routers. So this is just some code fragment that I've whipped together to illustrate how you might do it. If all your intent is just to pull route objects out of a database that are associated with an AS. Now what you can do is, with the route objects, is you can query a database and ask it for, put an inverse query on, say, tell me all the route objects that have an origin of a particular AS, and then it will give you a whole list of these, and this is how we're going to use, what we're going to use to actually build the filters. So this is just a bit of template that is static. So you put this in a file and load it into the router and forget about it, usually. So this is, in fact, a peering policy, setting local preference, setting some BGP communities. But the main thing is that it's going to act on a route filter to select routes that it's going to accept. And so here's the base template for the policy fragment RSAS 6939. Again, that's static. And here's just a bit of code from the RT config that's going to populate the prefixes term to do a match on all the route objects that have an origin AS of 6939 and they're bigger than or equal to a /24. And they're not part of the Martians. And now I'm going to flick back to Barry. Any more questions?
Actually, we have lots of questions. Okay.
Looks like we got a question. You got a question?
Oh, yeah.
Yeah, there was a piece of software that wasn't identified. Tom Daly from Dynamic Network Services
IRR Power Tools, it's available on SourceForge. Richard Steenbergen, who used to sail around the Nanog quite often, made this available. Works real well. Does pretty much what the IC tool does. It's just updated a little bit newer.
Can you pop an email message over
Sure.
to
Yep.
me? Because one of the things in the follow-up action item is I did this years ago on the security part, and I'm thinking about doing it again on the Nanog page, is to just collect every single resource we have on this, this whole body of work.
Absolutely.
All the tutorials, all the sessions we've done, and have like a page on this with it, and all the tools. Because we got a lot of different research tools that created around it. Yes?
Yes, I've also been talking with Paul Vixie at ISC and a group of RTconfig users in hopes of improving the status of RTconfig. So there is still some hope that it may or may not return to some sort of life.
Yeah.
Well, I also heard rumors about this, and we are pushing for it. There are more tools using the databases. Last time I checked them, they all were kind of lacking something, and the ISCR thing certainly lacked, kind of quality.
Some parent fundamentals. So let's step back out of the policy tool of having your database and on parent, because what can you do now if you're a, small, medium service provider, you're multi-homed, what sort of things can you do now? Principal guarded trust. We set up our policy mechanisms with BGP where there's a check and balance to it. When I advertise out to my upstream or my peer, I set up a filter of saying, here's what I'm going to advertise to them. On the opposite side, because we're peering with each other, we've agreed upon what I'm going to send them, and they're going to send to me. I put an egress filter out to say, here's what I send them. They set up an ingress filter to put a check on that. And that sort of check and balance is kind of how we've kind of built the net with it. Now, a lot of times people forget that, and this applies at any of the BGP boundaries. Any of the BGP boundaries, just check and balance. You put a filter saying, here's what I send. The other side sets a filter says, here's what I receive. Have agreed upon contract. And a lot of the large RSPs, this is contractually spelt out. You have a contract and says, here's exactly what goes between these two parties, and there's a contract, and you build a filter on both sides to enforce the contract with it, right? So that's principle with it. So you got to know, though, what you're going to send, right? So this goes back to knowing your network, right, and setting up on the customer side. So where should you filter? Well, so the first one, this is obvious. I'm going to emphasize this point over and over again, especially on the customer side, all right? Anything coming from your customers, you need to put a filter there to filter coming in, and this is one of the areas we see as big lacking. Lots of people got the filters coming from their upstreams and their peers, right? That's not rocket science. So we don't have no problem with filters there. The strength of those filters may be in question, but we do have the filtering coming in from there. Our problem set that we have in the community is the filtering on that side, on the customer side. That's the big gap in there, and that's where we see the mistakes usually coming from, right? The other areas we have what we call policy containment filters. In other words, set up the filters on the egress. You'll set up your filter and say, here's what I send to you based off of business practice. But a lot of times people don't think through containment filters. What if Murphy's Law of networking kicks in and takes over, right? So Murphy's Law, anything that can go wrong will go wrong. Murphy's Law of networking, anything can go wrong will go wrong at just when all your customers are online, all using your network simultaneously and at your peak hours, right? So the Murphy's Law of networking is really bad. And this kind of happens out there. And you also have the MIT problem, not the Massachusetts Institute of Technology, but the thing that was grilled into me from the radar days is this is maintenance injected trouble, right? So, you don't want to get maintenance injected trouble into your system there. And that a lot of times happens. Yes?
One other boundary, in addition to the EBGP boundaries with customers, is the internal EBGP boundaries in between confederations. Is looking at the areas inside your network and making sure that you don't allow an instability that gets introduced by the failure of a customer prefix filter to propagate across your network and break the routers on the other side also. So. that's another area to watch out for.
Even beyond the communities, you have areas, now that a lot of the large ISPs are large and geographically dispersed, you have natural points where you can put containment filters to keep damage within your network contained to a certain geographical area. You know, transoceanic systems, intercontinental big backbone links, things like that. You can kind of see how they are. And I've seen some service providers do that sort of containment on a geographic boundary. But then you go like, well, all my multi-home customers, you know, what do I do about multi-home customers? You know, it gets hard keeping track of all those sort of things. You know, you got to know what you're going to accept and what you're going to advertise. Bigness is not really an excuse. And I've heard this from a lot of big providers who say, oh, I'm multi-home and this doesn't work. But then I see another big provider and it does work. So what happens with this is, you know, containment filters, you go back to this scenario and say, oh, let's advertise in the entire /24. If you have these containment filters in there, right, and say the filter breaks and, you know, my customer filter says I shouldn't allow all these /24s. And that breaks, right, because somebody forgot to apply something on a provider edge router. And that happens. That's just human entropy to a system, right? If I have a containment filter that says I do not export /24s out of my system, right, then those /24s would have gone from your customer into your network and then hit your border. And because you put a policy in and say no 24s out of my network because I don't want to send any 24s out of my network, they would hit your egress filter and stopped. Okay? So that's thinking ahead of saying that, yes, I filter my customers, but what if the customer filter breaks? Let me put up a filter on my egress policy, which is, what if stuff breaks? What am I going to do? How can I put things in there to contain the problem? Because what is the damage to you if you start sending out /24s? Traffic starts coming to you that you may not want to come to you, right? That's why we do this. You're protecting your business with these sort of policies in there, right? So again, monitoring the table, things like that with it. Some quick summaries in here. So I'll just flip through these summaries so we can go to the next slides. Understand your network. If you want to deploy voice, video, any of those services, you got to have these services up and running, right? I mentioned a point about regulators watching your network. What do you tell a regulator when you say like, oh, well, you know, somebody in the other side of the planet advertised our prefixes and our video service or voice service went down? Regulator's going to say, well, why haven't you done something about that? You know, you know, that's a country on the other side of the planet. It shouldn't affect you. Understanding your techniques, and we're going to be getting into, you know, understand techniques to help protect your equipment. Review, and I think when we pull in some of the next sessions we want to generate, it's interesting how much has happened on the vendor front from a toolkit of what you can do to help to apply policies. So here you think of a policy and you say like, there are features out there that vendors have that is a knob that you can provision on the provider edge equipment to make sure that somebody doesn't go out there and hijack an autonomous system that they shouldn't have, or starts prepending things they shouldn't have. Well, there are tools there, but I know a lot of service providers, they're thinking of the feature set of controlling my network back 5 years ago. They haven't refreshed with all the new widgets you can take advantage of on your equipment that's sitting there today. These are widgets brand new. So it's interesting. One service provider 4 years ago, I had did a review of all the BGP features that were added into Cisco iOS over the past 5 years, and this is 4 years ago. And they were wowed. They say nobody ever told us that you have all these new features. They're sitting on our router today, and nobody told us that we have all these new features. So vendors, right? Cisco, Juniper, Foundry, all us vendors, we do a very poor job of updating the broad community that, hey, we have this brand new feature, because we're so business driven. You know, you're my customer and you're telling me, get this feature in or I won't buy your equipment. So we put that feature in, you have this feature, and you're happy. And we make the deal. And we go to the next deal, right? And we don't go around and tell everybody else, hey, we got this new feature, because the person who wanted it was this customer and they bought it. This is the business dynamic going on. So vendors are not incentivized to go out there and say, okay, we won that deal. We're looking at the next deal. That's our business driver as a vendor. We're looking at next deals. Right? As a result, you get all these features out there. So that's one of the things to go look at. If you haven't pulled your vendor in, or vendors in plural, and says, give me a review of every single feature you got in BGP. Tell me all the ones I don't know about that I may not be using that could make my life easier. Right? So this is one of the areas of review with it. Some of the things, what the prefix filtered on, especially on these things that are not rocket science. Designated special use addresses. We now have RFC 3330. Right? Addresses out there that are designated for special use that we shouldn't see on the net. Right? So if you shouldn't see them on the net, you can filter them out safely. Right? And some of these, for instance, you got these addresses out there, loopbacks and private nets and things like that. Pretty obvious in the list here, right? So these are quite obvious ones that go through, and the filters aren't hard to build. Bogons. Oh, Sean, yes.
Just to go back to that previous slide, I am putting out an update to RFC 3330. So if you're using that list, then you might want to check the update.
Yes. So, and the update is we got some addresses like the lower boundaries, right, being allocated out, right. So we have, and that's actually 3330 does a good write-up when you look at the description for each of them. So you pull that RFC out, you look at it, and there's addresses which are on boundaries of the B class and C class and those like that. And those are ones that could be allocatable now. So they're going to work the allocations for those. So, and they're well documented in here. They say they may be allocated in the future. And what Sean's pointing out is they will be allocated in the future. IANA's coming out with a document that says they will be.
Yeah, they took the word reserved off. So it's no longer they might, it's now they will.
Yeah, they will. They will allocate out. So Bogon addresses, which kind of gets along with this, this one source over here, which is the IANA assignments, is where the kind of source you use for the Bogons. Now, what a Bogon is space that has not yet been allocated by IANA. And there's a list that IANA maintains that says, here's what we've allocated, here's whom we've allocated it to with their RIRs. What's interesting is we're approaching the point where Bogons are a thing of the past because everything will be allocated out. And then you'll have to not go to IANA because IANA will say everything's allocated out in IP version 4 and moving on to IP version 6 on what they're allocating. And then IP version 4, you'd need to go down to the regional registries to get the details from them to find out what's out there. Several years ago, a bunch of us got together and started a Bogon project. That project is still going. It's active. It's a starting point of collecting all the information about Bogon filtering, what you should be doing with Bogon stuff. So you got the place on Team Cymru sponsors it. We got templates out there to help people get started with filtering. These are templates that are designed to be cut and paste. If you haven't done any filtering before and you want to do an ingress filter, you can take these filters and cut and paste them into a router, and they'll work. Mine's a little bit. Mine's two versions behind, so I got to update mine on there. There's 3 modes: build your own Bogon filter, use one of the templates, and then the third system that a lot of people don't realize is we have this thing called the Bogon route server, where, because the problem with the Bogons is you have to maintain this, right? IANA keeps on allocating, right? And if you're doing Bogon filtering and IANA allocates a block out there, you got to maintain it, you got to update it, you got to look at it every month and find out there's new allocations. I got to change it. Otherwise, you're going to have people on a net who are getting new addresses out of new address blocks, and they won't be able to get to your customers, and your customers won't be able to get to them. So what Team Cymru did is they say, let's set up a BGP router, and we'll do an eBGP multi-hop to you, and you set up a filter, and if you get this particular community for these Bogons, they'll advertise the Bogons to you, and you set up the filter to null zero it. So you null zero the routes and drop the prefixes so you don't carry them. So you get a benefit of the null zero benefit, and you also get the benefit of not routing them out there. And the details and instructions are all on that page. And there's some people who use that.
An example problem with static Bogon lists. There were all kinds of problems getting a 69.x for quite a while, and Cisco's autosecure feature included a static Bogon list for a while. So it would be whatever it was at the version at the time the iOS was created, and of course that was right for about 8 minutes. So that and it tended to be done to be used by people who were not then maintaining the lists. So
yeah. So the net police concept. This is a filtering concept that as you come up with how do you set up your filtering architecture. Yes?
Can you go back to the Bogon stuff?
Right.
I think it is important to clarify that using the Bogon feed means you will most likely, if you follow the instructions, have null routes for the aggregates that you learn from the Bogon servers. But until you do the route filtering, you don't prevent yourself from learning any more specifics from within that range.
That's true.
So there's a lot of ability
Yeah.
to get overridden,
Right.
which is why I do the manual filter.
Do the manual filter. That's true. Then think through that. I haven't used it myself. I was just advertising the Cumry the services is there. Of course, I'm a manual sort of guy. I like to have my own database and then do my own configs and have control over my configs is my personal management style. But you want to put all the options out there because different networks have different requirements. So net police filtering. This is a coin I termed years ago based off of this philosophy of taking what the regional registries give as their boundaries of allocation. So a regional registry will get a big block from IANA. The regional registry then has a policy group, and since each regional registry is a bottom-up policy mechanism, in other words, the membership figures out what their policy should be, right? So RIPE, RN, LANIC, APNIC, they all figure out what their policy should be, and then they say, here's our policy. And the policy would be, say, okay, for this block of addresses, our minimal practical allocation, is a /20. In other words, we're not going to allocate we're not going to allocate 21s and 22s and 23s, 24s. We'll do a 20. We'll do we'll do like a 19. We'll do 18, but we're not going to do anything in a longer prefix, right? We're going to that will be our minimal boundary. And then someone came with an idea, says, hey, instead of upgrading my routers because I get all these prefixes I don't really need to carry, I'll filter on that boundary. I'll just filter on that boundary because I, as a business, decide that this is what I'll do. That's where this idea came from, is they say, first the RARs came out with this concept, minimal practical allocation, and then a couple of businesses, right, these are service providers, our peers, running as a business, came up with a business decision and says, look, I don't need to carry all this extra stuff. It doesn't do me or my customers any good. I just won't carry it. I'll just filter on that boundary. So there's two modes of doing this. There's one mode where you take the minimal practical allocations and you filter hard on it. Whatever the regional registries say, that's what I filter on. And then the other way of doing it is to say, here's my, I'll just do it all at 24. So the first way, we call it strict mode. The second way, we call it loose mode. All right? So the strict way and the loose mode of doing it. All right? There are sites, each of the regional registries have different sites that they say, here is all of our allocations, and here's the minimal boundaries for each of them. Right? So they'll set it all up. So it's all well documented on the net. It's easy to go check on to do that, sort of work for that. And this is an example of what a filter would look. So this is like a strict mode where I say, okay, here's an APNIC filter, and this is old. Don't look at this. This is really way old. This is years old. But it gives an example of how I would do like a greater than, less than, greater than 9, less than or equal to 20, right? As one style of doing the filtering, all right? But you have to understand the consequences of this, right? So this is a business decision. When we talk about protecting your business, this is part of your business decision. You have to think through what's good for my business for this, right? Taking in more prefixes, take up more memory, all right? Taking up more prefixes smaller could take up, churn time. I have maintenance overhead. It will cost me more money to maintain this, right? Doing this filtering in this way. Because I have to make sure I check with the regional registries and what their allocations are, because they are not static organizations. Each of the regional registries are doing their updates and things like that. There are holes in this. Like, for instance, each of the regional registries now have infrastructure allocations that they carve out. For like, okay, here's for exchange points. Here's for, things like that, right? So there's things of how you do that. Yeah, question. All right, so you have to understand the consequences. Think through with it. So this is the second one where the strict mode, the loose mode where you prevent to 24. Yes.
Well, okay. 1 point for kind of the consequences. I think it would be a very good idea. Anybody who does such a policy actually should publish that he is using such policy, so that parties that actually deliberately are just doing more specific announcements at least have some point they can be pointed to. That, well, okay, if they do it this way, they will not be reachable.
Right. That would be a good thing for the rest of the world to know if you actually make a choice to do this. And now why, so I'll give you the business reason why you want to publish your policy. So the business reason why you want to publish a policy is it saves you from getting a phone call. Phone calls to your NOC, phone calls to your help desk cost money. And if I can publish a policy where like somebody in Germany can find out somebody in Singapore has got a particular policy and they can look online and they know what the policy is, then that person isn't going to call me. They will know what's going on. All right? So that's a business reason why you want to, equate it back to the business. There's good business reasons why I want to take, if I choose down these paths and update my policies down there, this is why you want to make it public. So everybody knows exactly what you're doing with it. And again, this is an example of, everything's at 24. This is a loose check. So strict check, loose check. 2 different modes with it. Bottom line with this is, it's interesting. One large service provider who had to be called was doing this technique during 7007, and didn't even know that there was something going on out there. Their routers were not affected. Lots of other service providers, their routers were affected. This particular service provider, their routers were not affected at all because they were using this approach to protecting themselves with ingress prefix filtering. Right? What happened in 7007? The net deaggregated. What did this network do? They filtered at the regional registry boundaries. That means all this deaggregated prefixes, they hit their filters and their filters dropped it. Didn't touch their routers at all, right? So it's a technique that some service providers will raise their hand and say like, hey, it saved us. Now they're speaking as a business. And remember, this is all going to the realm where this is all the NGN, this is the business part of why we should be doing this filtering, to protect our business, right? So it's a proven tool. And these templates, both the templates Steve did and I did, we have in here ingress prefix filter and strict mode, loose mode. There's actually 2 filters, strict mode, loose mode, maintaining it. And part of the reason to maintain it is all the new regional registry allocations for the templates in there. Saying again, all right, customers. If your customers speak in BGP, you need to put a BGP filter on it to protect your business, all right? Because you can easily have a scenario where here he is, why is he speaking BGP to you? Because he's multi-home. He's either multi-home with 2 connections to you or multi-home with a connection to you or a connection to somebody else, right? So he can have, a policy with this particular net block. He should only announce this to his peers, should only accept them from his peers, and then, you should have this strict in there, but then, customers will start coming up with excuses. Oh, man, this is so hard to maintain. And it is hard to maintain, but the consequence is simple. Let me just flip forward here. This is the consequence. And I've seen this happen so many times. It's funny. One of the wildest cases I had, I was working at Singapore Telecom years ago, and I'm doing a trace route to Japan, to KDD. And it's congestion, right? I'm going like, what's going on with this? I'm trace routing this, and it's going out to the University of Singapore. From the University of Singapore, it's going to NEC's corporate network that happened to be connected to the University of Singapore. From NEC, it's going up NEC's private backbone into Japan. From NEC's private backbone in Japan, it just exits into Japan itself. So here was basically a configuration policy mistakes chained on top of each other, where I had all of my commercial traffic going out through a university system, up a private backbone, into Japan, and that became my primary link into Japan. I was scratching my head, why is this going on? Right? And why this was going on was the filters were not set up properly in multiple places. My filters weren't set up properly. The university filters weren't set up properly. KDD's filters were not set up properly. Right? So it took a day where we all had to go through and say, we had to all clean up our filters, right? Because everybody's filter was all messed up. Right? So there's a case where I was the one part of the chain of calamity of errors there that caused all the backbones go up there. He's got a war story.
And I'd like to just point out, AS path filtering is not good enough. That AS path filtering does nothing to prevent any of these problems. AS path filtering is very nice to solve certain types of problems, but not this. And it is completely insufficient. So it should not be looked at as any kind of serious protection against a deaggregation event or a hijack event.
Right. These days, when I set up my filtering policies, when I'm actually sitting down with a customer, it's using a combination of a prefix filter and community filter and AS path filter. And each of them has their strengths, each of them has their limitations, and then you kind of work with them together to actually reflect what your filtering policy is. And a lot of times I help the customer sit down and force everybody to write down in English. They want to get into configs a lot of times, and I say, no, let's write it down. Let's write down policy and what do we want to have happened. And then once we write down what we want to have happen, then we look at our three tools with prefix, community, and AS path, and we find out how do we express that policy now in a configuration. So writing a policy down is important, because if you jump through and says, I'll use AS path filtering for everything, well, it's a tool that only does certain things, a tool in your toolkit, all right? Saying again, prefix filtering to your peers, right? Prefix filter is all to your peers. This is going out to your peers. Certain things you should filter. You don't want to send designated special use addresses out of your network. You would be embarrassed. You don't want to send out net 10 out of your network. You will be embarrassed, all right? That happens every now and then. You don't want to send default out of your network. I've seen that happen once. That is weird. It was weird how far it went before it got dropped. So you don't want to send out lower boundaries. Yes, you're going to, inside your own business, you're going to be doing funny games to maintain your business, which means you're going to be playing around with /32 here and this, that, all over the place. All right? That's part of the business. We all know that. If you all run a network, we all know we've had to do these certain tricks to get a customer happy really quick. All right? You don't want to have any of those games advertised out of your network. All right? You don't want to all of a sudden say, hey, how come this network's sending out /32s? Now, if you want to know how bad it is, we have tables. Remember, on the internet, there's no place to hide. Right? You go to any of the public databases out there. We got many public databases, and you can pull up reports. How many networks are advertising the /32 right now? I bet you those of you with a computer right now, one of you can probably go to one of the tools and pull up and says, oh, right now, at this instant, this how many autonomous systems are currently sending out a /32. And we have, it happens all the time. Don't be one of those guys, right? So, but these egress filters, right? These are protecting the industry from the stuff. They can get very large. So this is why you want to, ask these questions. What do you allow your customers to do? How do you advertise your prefixes out? What communities, right? One of the questions a lot of service providers ask themselves: do you really want to send your communities out to the world? I mean, a lot of times your communities are for your own management. Do you want to send them out to where the rest of the world finds out about them, right? Like one of the things I realized today is I want to go back to the database to the Pakistan incident, and I realized because of the way it was propagated through the net, I can probably find the community, the black hole community they used, because it would have been recorded in one of the historical databases. So I go like, I realized that because that's what happened. They didn't put a community filter in. So here, this is where BGP community filtering has a strength, right? Is if your prefix list starts getting very, very large as you're trying to put every single customer's policy in there, that could get too large for the device you have on your gateway, right? So this is where a community filter becomes a tool, right? So each tool set, community filters, prefix filters, AS path filters, you have different ones with different tool sets. And then filter and from the peers, again, protect yourself. Ingress filters in there. This is just summary. Some of the things in your filter, you can look at the template. All these things are kind of like in the template. If you have in here and you've not doing ingress prefix filtering now, just pull down the template and read the template. Because what we did is when we did this template 4 years ago, we tapped in the brains of a lot of people and kind of come up with, kind of like this list of what you should be filtering. Like, for instance, one of the things we put in there as notation in this template is like if you are connected to an exchange point, then a lot of times the address boundary on your exchange point is not, the exchange point policy is, say, take this /24, say a simple exchange point for /24. This /24 shouldn't be advertised to the outside world because it's an exchange point just for those members on the exchange point, not for somebody on the other side of the planet, right? So you shouldn't be receiving this from any of your other upstream connections. The connection on the exchange point, yes. Other connections, no, right? So it's things like that popped up, and we documented that in the template. So the template is as much as for ingress filtering, a place where you can read through it and say, I didn't think about this, I didn't think about that. So just reading through the template, and then we're going to be refreshing. I'm going to be sending out to a bunch of people. There's a whole bunch of emails, addresses on there. People helped out think about how to build it. We're going to go out to those guys again and consider others.
Let me call special attention to the second bullet. Don't accept your own prefix from a customer. That's no more specifics. Yeah, and no more specifics of your own prefix. I've seen several cases where providers who should know better accepted routes to their own DNS servers and things like this from their customers because their customer put in a static route, redistributed static, and they accepted it. So,
but if you allow your customers to use /24s in the process of their multi-homing, and their link to you goes down, you cannot reach your customer.
When I say your prefixes, I mean the prefixes that you yourself are using. For instance, the ones to your DNS servers, the ones to your loopbacks, not the ones that you have allocated to customers that they can then use for multi-homing. Don't let them announce your AAA servers either.
Yeah. Of course, I would say you shouldn't have anybody access your AAA servers. You shouldn't advertise it at all.
True.
Let's walk through, how do you work a prefix hijack real quick, since we're getting ready to finish up here. Because this happens a lot, all right? So here's a scenario. Here I am, customer, I got a /19 coming out. Somebody injects a /24 for my DNS server. All right, same scenario here, infrastructure stuff. So you got all the DNS traffic now routed over there. Then you start asking questions. First thing, how do you detect that the hijack is happening to your business? All right, who is doing the hijacking? I don't know. That's sometimes a hard question to answer because especially if it's criminal. What are they doing? How are they doing the hijacking? Who do you call? How do you influence change? Because now you're trying to influence change throughout the entire internet, right? How do you find the people at the hijacking ASN to help? How do you find them? Right? A lot of times, one of the biggest problems we have on the net is just finding somebody to pick up the phone at a particular autonomous system number. What if an ASN won't help, right? Because we've run into those out there. So this is where preparation is key. One of the things I've seen in working hijacks and monitoring hijacks and then being, paying particular attention to this whole attack vector on the net, this whole incident vector on the net, is that preparation is really key. I mean, being able to, simple thing like having the phone numbers of all your peers and upstreams and their chat addresses so you can call them up. Because what I found is the best tool that you have available to you to resolve a hijack case is you get on the phone with your buddies at your different upstream providers. You start working it. There's a variety of different things you're going to do, but you know what? If you can't reach your buddies and different service providers, there's a lot of things that you just cannot do on your own autonomous system. You need to collaborate with your peers on the net. Collaboration is key. And that's something you can't wait until the incident happens. You need to prepare for that. Meetings like this coming to Nanog, so some of you are wondering, how do I justify to my bosses that I need to be at Nanog? This is one of the investments. You explain to them what a hijack is, how a hijack can affect my business, how a hijack can disrupt my services. And to prepare for a hijack out there right now, in the future, people are looking at, we will have the tools in the future to not have hijacks happen. But today, hijacks will happen. Tomorrow, hijacks will happen. 2 years from now, hijacks will happen. All right? So this is why I need to be at NANOG, to build this peer list, right? Go out and get the green dot, right? I'm the peering guy, right? Or if I'm a security guy, get the black dot, right? So, is deaggregation an option? Because some people say, well, let me protect myself by deaggregating every prefix I have, right? So is this really an option? The hijacker injects a 24, you inject a 24, they inject a 25, you can inject a 25. Will a 25 even work? I don't know. Who has the better AS path? I don't know. What about those networks that filter on the boundary, right? There's all these questions that are popping in there with the hijack work, so work it through. And then when you look at it, where do you do different things, right? So you got like down here in AS200 where the hijack is being originated, maybe that autonomous system isn't cooperative. But the upstreams from that autonomous system, is there things that they can do on their part, right? Don't know. They may not be prepared. As we saw in the case with Pakistan, Reach was not really prepared to do anything. They were going like, what do we do? What do we do? And they didn't really think through, what if somebody hijacks a downstream from us? What can we do? Can we do a filter, drop in an ingress filter that filters that prefix? Well, they weren't doing any ingress filtering on their peers. They didn't have the ingress filtering in place. So, you run into these sort of, what do you do at each point? And this is an exercise that each organization should walk through with themselves and say, here's our network map, here's how we're connected. Let's do a tabletop exercise of how would we work a hijack, all right? Because, right now there isn't a big motivation for these hijacks to happen. So when they do happen, fortunately for us, they've been maintenance ejector trouble. There's been somebody who did something, it messed up, and then a calamity of errors happened, and it had a consequence on the net, all right? That hasn't been intentional. So speaking of which, what happened? Well, what happened was the government of Pakistan was upset with YouTube, right? And they did what's within their rights as a national government to say, we're going to protect our citizenry, or we're going to filter, or we're going to protect my stance in the government, whatever. National governments have authority over the citizenry to do certain things, and they put out an order to the telecom providers. They say, go filter this. So Pakistan Telecom is like the big choke point, all the stuff going through Pakistan Telecom. They decide, okay, what's the quickest way for us to execute this order from the government? So they go out there and they basically say, I'm going to use a remote trigger black hole. Very simple technique, one of the most common techniques we use on the net today to protect themselves for DOS attacks and other activities. So it's a well-known technique, very stable. I'm going to go out there and advertise my list of black hole prefixes for YouTube. I'm going to send that into my network. So I go out there and send it into my network, and it gets propagated out. No problem. Government order executed. But there was a problem. They use community-triggered black holes, which is the common way that we do it. All right? They didn't put a no export on it. They didn't have an egress filter, right? So what is the two things? Community filter. Even in our community specification, we have a safeguard. Safeguard is no export, right? So within our specification, we have that in there for that reason. Then you can also put a egress filter going out. We can do an egress filter and say, here's the only routes I send out. That would have protected it. I could put an egress filter and says, don't send anything with these communities out. That would have protected it. But there was no egress filtering at all. So it leaks out, all right? Then it gets to reach. Continues. And if you want to see the dynamics of this, how many people here have watched the video from RIPE? The RIPE video, okay? So on this link, right close to the beginning, I didn't put it in this section, but in the beginning where it's talked about why we are here, there's a URL at the bottom of this, so you can pull down the slides. Go to that and watch that, all right? It's when people ask about what happened, I point to that big write-up. And there's some really, really cool tools developed there where you can analyze this stuff, right? And there's a video on that tool set. So instead of looking at the tools and starting to play with it, watch the video first, and it's pretty impressive. And that tool set is available to you. All right? It's available to everybody here to look at that tool set and play around with it. That's a tool set that's available to the community just for doing that sort of analysis. So I highly recommend everybody watch that. And then think through with this, the way the filters are supposed to work, and think through and watch this tool, because you can see prefix goes out, next ISP, next ISP, next ISP. What happened? What could, if I was on that chain, what could I have done to stop that from happening? If that happened to me, if I was in YouTube's position, what would I have done? Right? And that's kind of what this session, summarizing up what we're about, is when you look at that video, you kind of go like, what could I do to not end up in the same boat as YouTube? What can I do to not end up in the same boat as Pakistan Telecom? Because it can happen to any of us if we don't think through this sort of thing. So, anything else?
That's a lot. And are there any questions? Any
Questions on?
Practical implementations?
So you spoke at one point of having a database that contained all your prefixes and all the customers' prefixes. And you talked about the route object, and the route object has the prefix information in it. What do you do to ensure that you're getting the correct information from the customer, and where do you get the route objects from, and how do you know that that information is correct?
The first part of that is your own routes, and the presumption is that you know what is that all the ISPs know what their own infrastructure routes are directly
Right.
the things directly allocated to them. So that can be assumed to be correct.
Barring fat-fingered stuff. And
Right,
all that kind of thing.
but that a mistake will turn up quickly. Then for customers, the easiest thing to do is have something that validates this against what their prefix list is. Validate this against what they are known to advertise, and make this a step in building the prefix list. That if it's not in the database, it doesn't make it into the prefix list and so they won't be able to announce it. So they might have a route that they're allowed to announce, but it would not actually be announced until it gets into the database.
So I'm actually going to punt this to the panel. So this session is the tutorial. We have a panel session on Wednesday, advertising a panel session. The reason I'm going to say that is because in this area, and Sandy, I know where you're going with it, and Ron, with the work in IETF and with the registry work and the CIDR work, is that I think, and I wrote this note down, I think we're exposing a gap in the work we're carrying forward with it, because there has to be, and I'll bring this up, I'll go up to the mic and we'll bring this up, good panel sort of discussion. There's a gap between, if I am a service provider, I'm running a business, right? How I know that prefix and I have the authority to route it is a business process. And it's a business process per a contractual arrangement I make with the customer. And how I set that business process up to make that contractual arrangement with the customer, I have to find some way for the registry community where we can map that in. Because we already have problems in the community right now where we have businesses who will accept anything per contract. And they'll route anything per contract. And then everybody in this room are a victim of that business contract process.
I wasn't asking about the work that's going on. You've talked about there's work going on. I was just wondering, what do you do now? What do you do about making sure that the information that you're getting is correct?
I don't think anybody does much of anything now.
Yeah,
my personal opinion.
Well, in that case.
It depends. Different providers have different policies on that, and I've worked for several providers who all had radically different policies. In general, if a customer is routing space that is given to them by the organization itself, well, you have a record of that. So you have your own internal record, and so you've created your own route object in your own server.
Right.
If they want to announce the space from their other multi-home connection, they can generally document that this is happening at the time that it's turned up. They may not be able to document it further down the road, but they can at least document it then. And so a lot of the decisions in the database maintenance happens only at the time of installation.
Okay.
What the missing step is is in the maintenance of the records. That to make sure that prefix lists don't get added to without route objects being created.
Yeah.
So, and that's just a missing step in process.
Okay.
And it can be automated. We can make it automated so that the way you add it to the prefix list is you update the record, is you update the route object.
And what
So-
about peering relationships?
That is a much tighter, that's a much thornier problem.
Okay.
But inherently, if you're only in most peering relationships that I've seen personally, a provider is only exchanging the routes they know and their directly connected customers' routes.
Yeah.
Those are the ones that are generally being
Yeah, but
exchanged.
a lot of these cases that we've been talking about, there have been a lot of peering relationships in the middle there that
Where
weren't being
but
Right.
there were people carrying things who were neither their customer nor their peer.
Right.
Well, that's a problem.
So we're actually short of time.
Right.
We have break, and then if we have time at the end of the NSPSec BOF. Is the BOF in this room? Next room. All right. So, if we have extra time there, if we carry on with that. And then we also have a panel session on Wednesday on this topic, right? So we have, more of this. And we'll look forward to your feedback, especially feedback for the next sessions we build in this area for the Nanog tutorial. So thank you for coming. And we'll see you around in the halls and stuff.